Okay. Morning, everyone. Thank you for having me. I am very happy to be here. Hopefully, I want to talk to you about a little bit about what I've done in Formula One and how we've transferred that to a data analytics modeling business which works outside of Formula One but with the same methodologies and tools. So that's me there. I started, my first job in Formula One actually was here at Stewart Grand Prix. So before Red Bull, this place was the Jaguar Formula One team, and then before that, the first Formula One team to move in here was the Stewart Grand Prix team. So I worked here in 1998 for 2-3 years. Before that, it was a cake factory. So it shows how much it's moved on. None of this stuff was here. And back then, the teams were around about 50 to 100 people. I then went and worked at what in today's teams is the Aston Martin team. It was owned by Eddie Jordan. And then I was 11 years at Ferrari and then latterly at Williams before we started the business in 2019-2020. So my generation, we were really lucky when we came into Formula One because we were probably the first influx of professional engineers, scientists, what would be called today data scientists, mathematicians, physicists, who came into Formula One en masse and then started to change Formula One into what you see today, into something which is very, very data-driven. It's very, very it's very, very crystallized in what its KPIs and outcomes are. And to build a data strategy around that is actually pretty simple. And as we grew that process, it became ever more important. I mean, we go back to the mid-2000s when we were actually controlling cars from the pit lane. This was pre the AI explosion, if you like, but we were already using neural networks to help us to control cars from the pit lane. If you look at where we got to at that point, we've probably taken it too far from a technology point of view and had to wind that back to something which is much more balanced between human or man and machine. One day it will be female and machine, but not for the next 10 years at least. So how do we use data analysis to leverage value within a business? Well, any business, your business, whatever your business is the same as my business, Formula One. And the beauty of Formula One, or the one significant difference, if you like, is that we use data to develop the fastest car, which is to win races. So you start at the end point, start at your very clear objectives, and then wind back. And we can talk about this a little bit later. But when we start to, when we take that methodology and we start to deploy that into the outside world with the tools that we've built, you'd be very surprised at the amount of people that don't actually start with the KPIs or have a number of opposing KPIs. KPIs in Formula One are really, really simple. You want to win the race, and to win the race, you need to develop the fastest car. And to develop the fastest car, you need to put a load of technology and science behind it at a rate of capability which is higher than your competitors. It's pretty simple. So how do we win a race through data? So we're going to concentrate on the operational element. So what you can see here is the cars in front of you. Some of them, which were actually all these ones over this side were actually quite painful in my years at Ferrari, but we won't mention that too much. But these cars, obviously, they're designed, so there's a whole design and development element, which would take place here at the Red Bull Technology Center. And then that would then get passed over to an operational team that need to take the car to the track and to optimize that car to the absolute 100% of what can be optimized in order that you win the race. So again, you start at the end, right? Start at the end point. You win the race and you work backwards from there. So first of all, let's have a look in Formula One. what are the contributing components. So like any business, Formula One, it's no different. It's made up of many, many disparate data inputs. So if you have a look, you've got the driver. The driver, as you see here, within this team here at Red Bull, you've got one that, in the common vernacular, smashes it every weekend, and you've got one, you never know whether he or his brother's going to turn up. When you have that situation, it's really important that you understand how to extract the most out of the driver. So what are the driver inputs? Because don't forget, Formula One, the beauty of Formula One, and the thing that draws me back, one of the things that draws me back to it all the time, is this blend of technology and science, but with a human in the middle of it as well. And when you have that, you have to understand the foibles and the nuances, and you can use data. There's an overarching AI and machine learning and neural network element to this, but you've got to be able to use that in order to be able to analyze your optimized output. You've got the team performance. So Red Bull are an incredible team. There's no doubt about that. The record speaks for themselves. One of the places where they are unbelievable, in fact, is in two areas of operations, of race operations. The first one is race strategy. They're very, very clever in race strategy, and we can get into why they're so good in race strategy. And the other place is the pit stops. So they haven't quite got the world record. Williams have the world record now, which I think is 1.81 seconds to change all four wheels and tyres. But they're pretty good. But again, having all of that data and having and having the tools to be able to analyze that data drives you to the to winning world records. You've got tire performance. In Formula One, there's three particular performance parameters that matter. The rest of them are window dressing. One of those is tire performance. Formula One, as an industry, has put a huge amount of effort into the analytics and the science behind tires, so much so that all of the tire manufacturers, the road car tire manufacturers, now rely on Formula One science to be able to help them with both performance and safety. The FIA, so the FIA, like your business, our business is exactly the same. We have a regulator. Nobody likes them, but you've got it, and if you didn't have it, the world would probably spin off its axis. So our job with the regulator is to move as far as we can towards into the grey areas and to the boundaries of legality. So all of the teams will be looking at that, but again, they will be deploying data science, analytics, and tools to be able to help them with that. You've got the overall car performance. So how do you optimize the car performance? So if you take a Formula One car, there's something like 2,000 components or parameters that you can change on a Formula One car, or will change for you, such as the external parameters, the weather, for example. So how do you optimize something with 2,000, a combination of 2,000 parameters? Again, it's not something that humans can do. You need tools and analytics to do it. The track, we just talked about the external factors. So the track is something that you're given. But each and every corner, each and every meter around a Formula One racetrack is different. So the asphalt is different, the micro roughness of the asphalt, the macro roughness of the asphalt. All of these contribute to how the tyre interacts with the surface. And you need to know each and every meter of that racetrack in order that you can optimize it. The weather is constantly changing. So, you may have a car that you think is absolutely perfect for free practice 1, but then both the track and the weather will change for free practice 2, and they'll change again for qualifying, they'll change again for the race. So you need to be able to constantly update your system in order to be within an optimized position. Competitor analysis. So Formula One is relative, right? Your business is relative. My business is relative. We need to beat 8 other teams or 9 other teams, 11 other teams maybe one day, if Formula One allow that many in. But you also need, it's all relative. So where do your competitors excel compared to where you excel? How can you beat them? How can you use your strengths against their weaknesses? How do you increase your weaknesses against their strengths, so on and so forth? So how do we actually leverage value from the data? Well, in Formula One, I think it's probably slightly different, or we're possibly a little bit more advanced in the way that we merge simulation, so take all of those disparate data sources, if you like, and then we merge simulation with actual results. So our job is constantly to take that, to take a virtual environment, which is what we put here, the forecasting and the sim models, to then come up with how we would run a race, or how we would design a car, or how we would optimize a tire, then to make that intervention in the real world, and to measure it, and to then start the correlation loop. And when you do that, you know, there's a lot of industries that we go into now, a lot of different sectors that my business goes into, and we start to deploy this methodology. We start from something like, you know, in Formula One today, we're about, depending on what sort of modeling and what sort of analytics we're doing, what area of the car, what area of the, we're trying to optimize, we can be up to 95% accurate in our predictions. So imagine having a business where you could be 95% accurate. And as soon as we say that, as soon as we sit around, you know, with a working group and the CEO of any business, they say, oh, we want to be 95% accurate. This started 20 years ago for us. So it's a long journey, and it's a long journey of constantly updating models, of constantly updating methodologies, and simulation environments as well. So I'll give you a quick example of what a race strategy looks like. So I don't know whether you can see the trace here. And in this particular example, so well done for whoever put this together, Max Verstappen wins the race. So the blue trace at the top means is the, as the higher you go up the screen, if you like, that is your finishing, the higher the average finishing position. So in this particular one, Max wins the race, Charles Leclerc is second, and then you've got all the other drivers. So along the x-axis are the number of laps. So we will have simulation tools. This is a simple output from that simulation tool. So how do we get to this simple output? What sort of methodologies do we apply in Formula One for race simulation? So we start with something called game theory, which is a branch of mathematics. It's a branch or number theory. And we build models around using this type of methodology. So it's a game, essentially. Formula One is a game. I'm sure the people, the businesses that are investing hundreds of millions don't see it like that, but it is a game at the end of the day. You've got 20 players from 10 different teams. And what you, effectively, the tools that we've built here help us to understand how each of the players will interact. So if player A makes a pits, for example, then all the other 19 players will be affected by player A, and so on and so forth. So this is a branch of mathematics. We're building more and more complex models all the time, so the levels of complexity are going up. Then they go into what we would call a stochastic output, so Monte Carlo simulation. So I don't know whether any of you would be au fait with a statistical approach like that, but you would run something like 1 million simulations every single lap. So every single, as the car is running and it's going through the 3 sectors, you're running literally millions of simulations per lap in order to keep updating with whatever the current situation is. And then you've got machine learning as well. So we have a machine learning layer into the tools that we've built. And what does that do? The machine learning, don't forget what we talked about, Formula One is a blend of machine and human. So there's let's call them 10 gatekeepers on the pit wall that have to make a decision when to pit the car and when to keep the car out, what tyres to fit. And all of those people are empowered to make those decisions based on the data that they've got. But they're 10 different human beings, and those 10 different human beings will make 10 different decisions based on the data that they are presented with, regardless of how the data is presented to them. So what you know, has become quite prevalent in Formula One recently is that we start to build machine learning models of what each of these 10 different human beings are going to do. And again, this is really prevalent or really relevant, sorry, to other businesses, because obviously you have a workforce, you have, they're all presented with data, so how do you understand what decisions are going to be made on the back of that data? So we deploy complex analytical tools to predict the outcomes, but we simplify that in the actual output to the user. as I talked about, they've been developed for years and years and years, decades literally, and that has got us to something like 95% accuracy. So we sometimes sit, you know, when I was really operational in Formula One, you would sit on a Sunday morning, all of the analysts would have been running these tools overnight from everything that had gone on during the weekend, and all of the, you know, don't forget, the analysis and the simulation and the build-up to an event starts 6 months before. This would have run on to the Sunday morning just before the race, and you sometimes used to look at it, and the simulation tools were so good that you knew exactly what the outcome of the race was going to be. And you're not allowed to bet on it either, which was always the downside. However, as we put here, there's a cautionary tale. We're talking about the moonshot for most businesses, and I know that because, you know, we work with lots of external businesses now. We're talking about you know, the moonshot. A lot of businesses come to us now and they ask us, you know, how can you help us with our data strategy? We want more data. We need to collect more data. We need to store more data or whatever. Data is actually nothing, and everything that I've just explained to you there is driven by insight. So data has no value, it's zero value. And I think Andrea said this at the start. Insight is everything. So in order to build insight, that's where the complexity comes in, that's where the clever stuff comes in. And like I've written there, our business, Formula One, is no different to anybody else's business. It's not that data has value in your business without insight. It doesn't, believe me. We've been through this. So how do you build a data strategy that drives insight into better performance? Well, there's five major, there's five core elements to it. And we're going to go through each one, or we're going to touch on each one, let's say. So it needs buy-in, right? If you're going to have insight, if you're going to have a data strategy within your business, it can't be something that you do from 3 till 5 on a Friday afternoon. It has to be built into the fabric of your business. So a Formula One team, the lifeblood of a Formula One team is data and insight, analytics. So they're driven by objective decision making. There's no subjectivity to it. You need a commitment to high quality acquisition, which means that you not only need to be acquiring really high quality data, you also need to be building solid foundations around your data architecture as well. Analysis and simulation, so analytics. So analytics is the merging of both analysis, so how you analyze something, and the simulation. And in Formula One, we've done a very good job of merging those two things together because they're all important. If you can't predict the future, if you can't forecast what's something that you can't measure, you're constantly just taking leaps into the dark. And then a business needs to be empowered. So it needs to be empowered and it needs to be motivated to use the data. So how do we motivate people to use data in Formula One? It's easy. If you use the data, if you drive insight and you drive objective decision making, you will add performance to the car, and when you add performance to the car, the outcome of your race will be better. And then you need to ensure that the feedback and the correlation loop is really strong, which talks to that point 3 there as well. So let's have a look at the first one, the buy-in and part of the culture. You'll be amazed at how many businesses try to implement a data strategy, and they're very proud of themselves because they collect a lot of data. You know, I have lots of CTOs and CEOs telling me how many petabytes of data they collect, and then they'll try to present this in a way to the people, to the decision makers within their business, in a way that is almost impossible to understand, you know, for even a data scientist. So we in Formula One, we're very much into, you know, complexities of models, complexity of simulation environment, complexity of analytics, but you must present it in a way that is simple to understand. So we've got something which is, you know, what I've said here on the left is big data, and that goes into, you can see that race output there. It's a lap output, which we would show a driver. It's 2 separate laps, so the speed trace is the squiggly bit that's going up and down. There's all sorts of different parameters on there. You would sit with, that would be something that you would sit with, you know, this team would sit with Max and Checo, and they would go through how each of them had optimized certain corners. You would go through each and every part of that and get down to a certain level of detail. It's very, very specific to that particular area of your business. There will be other areas of the business like the aerodynamic development, the tire development, the mechanical R&D development, that all of those areas of this particular business that will need different outcomes. They're all driven by this big data input, if you like. So, commitment to high quality acquisition. If you don't have solid foundations, then you may as well not bother. If you're just taking a load of nonsense data in, and again, you'd be surprised at the amount of businesses that do think like this. You know, I've got a load of data, it's all disparate, it's not normalized, it's not synchronized, but we'll try and drive some insight out of it. Don't bother. You're wasting your time. Just continue doing how you've been doing it before. I put a couple of different data architecture diagrams there. I'm not sure why, but we've done that anyway. But the main point here, what is really, really important, is that you can have all of these different disparate sources. So we went through that at the start of when we talked about tire data, aerodynamic data, team data, competitors analysis, timing data, car telemetry data. All of that is super important, but you've got to get it into a way where it's normalized and it's synchronized. Because if I want to look at what the car is doing if I want to correlate, for example, car performance with weather, that has to be synchronized and correlated. It has to be normalized, unless I'm not going to be able to process that data. And the other end of that is the high quality acquisition. So you've got to make sure that what you are measuring, the element that you're trying to measure, you're taking in really, really high quality measurement. It has to be within the bounds of what you're trying to measure. And again, if you look at Formula One, especially in aerodynamic, so you take dynamic air pressure measurement, the aircraft industry now, and NASA in fact, the space industry, relies on Formula One for that level of R&D. So all of the what we would call the MEMS sensors now, so to measure the dynamic air pressure surface of a Formula One car. A lot of that is directly transferable to the aircraft industry and the space industry. But again, that's only because what we're trying to measure, we want to get that as accurate as possible, because if you haven't got accurate input data, the output data becomes more and more difficult. And you need a really strong data architecture, because as I wrote there, timing is absolutely everything. There's no point giving insight to your workforce, in this case, Formula One engineers or performance engineers. There's no point giving them that insight 10 minutes, 5 minutes, or even 10 seconds after the point that they need it. So you won't do that without a really solid data architecture. So analysis and simulation, we've already touched on this a little bit. I've given you, the output here is a computational fluid dynamics output. So CFD is one of the principal tools that we use in Formula One to design the aerodynamic performance of a Formula One car. The other one being the wind tunnel, and that is there's essentially a loop of where we use simulation, and then the output of that simulation drives decisions or interventions that need to be made, which then drives the subsequent measurement of those interventions. It's a really important element of how we deploy technology in Formula One. Is nothing is deployed without a huge amount of simulation. So we have complex simulation environments, we have complex models, and by complex I mean high fidelity models, so very, very detailed car models. And because we have we have a high degree of correlation because of the amount of time that we've been doing it, we're able to deploy, say, a new front wing or a new rear wing, or a different weight distribution, or a different front spring rate, or a different rear spring rate. And we would do all of that in a simulation environment. So if you can do all of that in a simulation environment, and you can predict that you have a high degree of accuracy of what the actual output will be by the time that you go to deploy that. That's really, really important for any business. If you think that you can do most of your development in a virtual environment, that's not only is a massive time saving, it's also a massive cost saving. For us, it's important, not particularly because of the cost in Formula One, but because of the time, because we want to be able to develop our cars in a virtual environment before we actually commit to machine something or lay something up in carbon and make it and put it on the car. It's really important that we have a high hit rate as well, because if you don't have a high hit rate, if we just keep bringing a load of rubbish to the track, then you're not going to move forward. So simulation in Formula One and in lots of other business is particularly relevant. And then how do you empower the workforce? How do you make them motivated to actually use the data or the insight to drive better outcomes for your business? So I'll give you an example, and I touched on this before. Red Bull are incredible at race strategy. They are, I would say without a doubt, and all the other 9 teams will disagree with this, but it doesn't matter, I'm right. They are the best in the business at race strategy. And one of the reasons that they're very good is everybody's got more or less the same tools, right? Because we've all developed our tools to more or less the same level. But one of the things that Red Bull do very well is they empower their people to make decisions. So if you take other teams in the pit lane who are perhaps not as good at race strategy, then what you always find is that A, the outputs are never as simplified, but B, the team is not empowered to make decisions. And when they're not empowered to make decisions, what's the point in giving somebody all of this insight and all of these tools and then saying, but bring it back up to me and I'll bring it and I'll take it to my boss and they'll take it to their boss and eventually get a decision 3 weeks later, right? Give your people the right tools to be able to make decisions. And I put one here in front of you, which is actually it's not a it's actually taken from a game, but because I can't show you one of the team's dashboard. But this is the type of dashboard that the driver has in front of him, and this is using data and analysis to drive decisions. And the bit that I want to show you, the bit what I want to highlight, is on the right-hand side. So you can see that actually what you're looking at there are the 4 tyres. And if you look at the number in grey on the outside of each tyre, it's giving you a temperature. Now, why would you want to know the temperature? You would want to know the temperature because there's a closed-loop feedback there, which is essentially the driver will use this on an out lap during qualifying or on the lap to the grid or on whatever lap he's interested in to understand whether or not they've got the tyres in temperature. So in order to execute one of the parameters that's super important to be able to execute the optimized lap, the optimized 1 lap over in qualifying, is that you've got the tyre temperatures right. And the driver has to get the tyre temperatures right at the start of the lap. They'll use data output like this, or they'll use the output from the analytics. There's quite complex models that go into trying to relay back what the tyre temperature is. So they'll use quite complex models, like, but output it in a simplified way, so the driver can see. So at the minute he might want 78 degrees on the rear tyres, so you can see that he's 4 degrees and 6 degrees respectively away from that. So he's got to push a little bit harder. He knows what he'll do with the brake balance. He knows the interventions that he needs to make. But you're empowering that employee. The driver is an employee. You're empowering that employee to make decisions to drive a better outcome. It's a simple example that we can use in Formula One. But I think that the other thing that what we're doing here is we all know what the targets are, right? So if the target is 78 degrees, then everybody should be driving towards that 78 degrees, right? There's no ambiguity. You don't need ambiguity in your business. It's the worst thing that you can have. Leave that to the creatives. When you're trying to drive better outcomes via analytics, just have really simple targets. Have really simple targets. Have really simple outputs to your tools, and then you can empower your workforce to make better decisions. And then the feedback correlation loop. So we've talked about simulation, and we've talked about how important simulation is. But then if you take simulation then drives decisions to the real world, if you like. But you've got to make sure that that correlation loop is really strong. So you've got to make sure that you're using your simulation to drive a decision, and that decision drives an intervention, and then you've got to be able to measure that intervention. And to be able to measure that intervention, you go back to what we talked about before, which is the high quality acquisition. You've got to be able to make sure that you're measuring all of the right things in order that you can then feed back your correlation loop and update your models. And the whole thing is just a virtuous circle. It just keeps going around and around and around and around. And as we put there, you'll start with reasonably low accuracy. There's a project that we've just started actually for a certain sector, and they've never really done this type of thing before. We're starting off with, we started off with very, very low accuracy. In fact, we started off with about 20% accuracy. Within 6 months, we've got to 80% accuracy of forecasting the particular outcome. If you don't start it, right, you'll never get to this 90-95% number. That's it. You can do a clap if you like.